Today gonna make a recap video about the LinkedList, and because I want to test about my understanding, not about my remember about LinkedList, so I try to answer this concept by my memory and implement the course for this pages operation by myself. And I gonna start first with the LinkedList. What a LinkedList? For my remember, LinkedList is uh, collection or data structure in the Java. It's every language. I'm sorry. And the structure of the normal linked list is that it's going to contain the data and the pointer or the reference type. This is the uh, node, right? So and the reasons why we use the linked list over array stat, because the limit is one of the limitation of an array stat. Like for an array, it's storage in the stack. So for example, at the compile time, we declare an array with the size of 7, right? So it's gonna allocate the 7 space in the stack for it. 1, 2, 3, 4, 5, 6, 7. So for the array, we can allocate like a 7 element if we declare the size of this array is 7. And the problem come up when we want to add a element into this array. This is not allowed it because for an array we need to know the size of an array at the compile time. So if the size is, if the element exists at the compile time, it's not allowed it. So we using the linked list, because for the linked list, the memories, for example, the data from 1 to 7, right? I gonna allocate the data into the heap. So it's don't need because it allocate into a heap, so we treat the dynamic programming so that we can like ask the element no master, and we don't need to declare explicitly the size of this collection, right? We just, and we must the connection between the element in the heap kind of thing. This is the basic concept about linked list. And there are 3 types of a linked list: single linked list, doubly linked list, circular linked list. And they are kind of the same, but they are just some have some small different. So first I gonna come up with the single linked list first. So the linked list is something that we connect the element together, right? So there's no problem at the compile time, and we can add the element right this way. And for the first element, we use the head to hold the reference so that it keeps the structure for the linked list. And the last element, we use the tail node to hold the last node. So to display explicitly the head and the tail can help us to manage our structure more easily. So for example, for the element, this is the way we display it, right? And I call the element is the node, and inside the node I have the data, and I have the node itself. And I have the node itself so that it can hold the reference for the next. For example, for this element, the first element, this is the one node, right? And for the one node, it have to contain the data, and for this node, it has the data of 1. And for the reference, for the another one is the node, right? So I said this node is equal to the reference of this the second node. I store it at the memory, because for every I gonna use the Java to demonstrate in the code. So in Java, when we define the node, right, it is the reference type. It's not a primitive type, so it's gonna allocate into heap, and whenever, so I pass the element 2, and this is the same for the node 2, that it's gonna contain the data and the reference, the node, right, equal this node, right, the reference for this node, and it is the same. And for the last node, what it's pointing to for the node is going to point into the noon, right? It's going to contain the data of 4, and for the node, it's going to point into the noon. And this is all the thing. And I'm going to demonstrate some basic operations with the linked list. First is insert at the beginning, right? I'm going to remove the thing for this pointing to the noon. So if I want to insert at the beginning, what I first need to do is create a node, right? Create the node. For example, I want to create any value, right? I can create any value. So for example, I create at the 5, the node of 5, but I want to insert at the beginning. So what I first I create a node of 5, and then I need to reference to link it these two nodes together, right? So I gonna write the physical code for this relationship. First, I create a new node, new node, equal new keyword. I use the new keyword to create the new object, a node 5. So this is my new node. This is the step to create this node, and then I define the relationship between these two nodes, right? What I really need is that I need to this node pointing to this node and remove the head to this node, right? I have to have a 2-step. First pointing to the head, and then change the head to this inserted node, the new node, right? So first I use a new node net equal for the head, right? When I this one gonna point into this node because the head is this node the element this one anyway. And then the second step I need to do is change the head to the new node. So I'm gonna use like head equal head equal new node. Okay, this is all the thing. So I'm gonna implement this inside my environment here. I create a new project. Right. I demonstrate it in the Java, and Java allow this inner class. So for these collections, I gonna define another inner class. This one gonna be the node, right? And I just get as a private. And inside I gonna contain like the in for the data and the node, right? This class gonna have like a 2 attribute, 2 field, and I just declare as private. So I don't know, I'm gonna declare as a public. because when I display a public, the outsider can access it. The outsider is the single list collection can access it without calling like the setter, the getter, or the get setter. And then I must um, I made a constructor for it. Done and for the right, but um, I gonna manage the nodes by this outside class, so I gonna create some methods for this outsider to manage with the node. For example, I want because I want to have the head, right? So I define the head here and the tail here and the side, right? Because I want to know how many nodes I have inside. So I gonna manage create another field either side. So whenever I create a new node, this side may be increasing by one. And it creates like static. Even I don't display as static, it's still okay because all I do is just create one object of the outsider, so it's not affect anything when I increment and for the when I create new one for the insider. Right, when I create the side gonna increments by one, and then for the outsider I got this class the API inserting, right? I just get the public insert. Uh, I just get the void for short. It's better if I add the booleans because I can receive like some output. But right now I just discard the void for short and insert insert head. Right, because I insert this at beginning and I the input is like the integer, and so what this really do is that, right? The IR is a success for me for the HK where the head is equal to none. Right, I just write it down. Okay, tap for short. So if the head is equal to none, it's gonna create a new it's gonna directly insert to the head and set the tail to head. So what is really is that like the like when we declare, right, when the outsider know that like for the head is the null, right, which means that we don't have any elements in the list yet, so it's automatically inserts the head with the new node. Head new node with the element, and then it's going to insert the tail to the head because right now we have one element, so the head is still the tail, right? For example, we just create for the element of one right now, it's still the head and it also be the tail. This are a thing all the y. For example, when for this one, when I already have the head, right, I want to insert a new element right here, the element of 2. So this is the step. The first is create a new node, and then the new node pointing to the head, and the head to the new node. And we need to set the tail. For the tail, for example, if we have like multiple elements. We have to travel to get the tail to set it. So to get the tail, I think we have to travel. So I think we need to define another API here. It's gonna like travel to the end, right? What it really do is that it first creates the dummy node, right? Node temporary. It's gonna point into the head, and while the temporary have Nescat noon. But it returns the temporary, while the temporary Nescat noon is gonna return the nest. So the last element is a for example, I gonna set example for this one, right? It's gonna traverse from the node 1, 2, 3, and it's right now at the node 4. For next is 5. Oh, so it's gonna stop at the end. It's gonna return the end. So right here we just like basically cross the virtual end to insert back to for the tail. If we run I think this all the thing about the travel, right? For the travel we just do, and another is the insert as tail, right? I'm gonna write the physical code first. So to insert at the tail, for example, 1, 2, 3, 4, 5, right? For the 5 node like this, if we want to insert like the node of contain the data of seed right here, what I really need to do is that first we create the node itself. The node contains the element of seed, and then in some ways that the last element is gonna point into this one, pointing to the new element. So the first step is create a new element, create a new node. Node of seed, right? And then we want to traverse to the end, and then at this node we're gonna point into the last element. Traverse to the end, and the last node, the temporary, right? We declare at the temporary node, and this temporary node already travel to the end, and this gonna point into net equal new node, right? These are the thing, and for the new node net is by default is the noon, so we don't need to declare it right here. But I think it's the best practice to write it down, right? To traverse to insert at the tail, and we all really need to take care for the SK, like when the head is noon, right? When we insert to the tail, when we don't have any element, we just insert it at the head right here. Similarly, tail nest, because when we insert the data at the head, we already keep track of the tail. So basically we just assign it to the new node. But if we want to write out to be more specifically, first we need, right, all the things that we need to do the cell, the travel here. I just copy paste for the short. will not return anything, but the temporary gonna point into the new node. Right, so that we can keep track of the structure of our linked list. And the third way to insert is we insert at the middle and with the index for example. So we insert with index. So for the argument we're gonna receive the data, and another argument is for the index that I want to insert. Alright, this is our method. For our designing, we first I'm gonna write this first. For example, if I want to insert at 1, 2, 3, right? This is the index of 3. I want to insert the new element, for example, the element of 6 into this position. Right, I want to insert to this. What I really need to do is that this one, the element, this one gonna point in here, and this gonna point in here, and remove this connection. So it's gonna insert right here. So for the pseudocode, what is really happened is that first we already need to create a new node, right? The node of 6, create a new node. Here, this is a new node for us, and then we need to travel to this superficie index. So we use the for loop to travel for start index from the 1, I guess, because first we create the dummy node, right? That's gonna be the head, to travel from the head to this index, because we want to insert at this that's the index of 3, right? 1, 2, 3. So it's must to travel to this location 2, right? So first I gonna travel to here, and I gonna declare the dummy node temporary equal head, and I use the for loop start from 1 because it's already be the 0, right? So if until this less than sign, no, I'm wrong. While less than the index with the input we push to, right? The index is 3. It's gonna stop. So what I do inside the for loop is temp equal temp.net. So when it's out of the for loop, the temporary is gonna point into the current temporary is at this point. So what we need to do is that first we need to create a relationship between this node to the node of 3 right here to keep the connection. If we directly pointing from the temporary to this, right, this connection is gonna be removed, so we no longer know how to access this one. But so first we need to use the new node pointing to the next node of the previous one so that it can keep the structure of the list, and then we just basically point into the new node. So first we new node equal for the temporary .NET, right? When we .NET, it's going to access to this one, and then we for the temporary net to the new node. Done. This is all about this. So first I declare the new node, and then I call the dummy node, and then I use the for loop. Done. This is all about this one. So I'm gonna test this into main. So for sure, it just asks me to print hello world. I forgot to write API to display this list, so I'm gonna write here public void display this other thing that we display the dummy node, and then it's travel through the list, and then we print it out for the data. No, I forgot to print it out. Three, two, one, right? Because we insert at the head, so the latest element is the head, so it's printed in this order. For the well displaying, I not print the new line, but the temp this. You see here, right? This is the order of this list, and then I'm gonna test for insert. A tail, for example, 78. Anyway, I forgot to display it. Alright, this is the new one. Alright, I separate, so it's gonna wear displacement. I insert at the end, and then I insert at the middle. For example, I want it 3, 2. For example, I want to create a new node that holds element of 5, and I want to do it like that. 3, 2, 5, and then 78. So dot insert with an index, right? It is the data, right? I want the data if file is artist position is 1 2 3. Okay, that's all things as one that I want to display the list again. Maybe I implementing something wrong. Let's see. For insert with index, right? I'm gonna change little bit right here for the displacement. Data index, and then first gonna create a new node and then travel to this point. Let's see. First I create a new node and then I create a dummy node, I export into the head, and then I use the for loop that travel to the position that I want. This is the index of 1. New node is equal to temporary.next is with this one, this side, this side, and then I want to ask my friend. Let's see. Few issues as need to physics assign next to new nodes with strong understanding should be new node next should be a temporary next. I see the point. New node net is equal to temporary next, not I know. Right now it should be right, and then I forgot to include the SK for this one. For example, if I want to insert with the index, if the index is 0, right? If index equal 0, well, it's remain that it's going to insert as a head, so I just call my API here insert head, right? And if the index is equal if the index is equal size insert tail, so that I can handle the SK for inserting with an index. But I think there's some with the size right here. I should declare it as a 0 or 1. For example, the index of 1, 0, 1, 2, 0, 1, 2, 3. So the size should start from 0. So the first node either 0 right? And then experiment for the second is the one. It's keep the order of the normal index for an array. For example, for easy, I not declare the first index as one. I just use as a 0 for the easy 0. And then delete from the end, delete for delete. So for deletion, as already covered about uh, iterative reversal. So for deletion, what I really need is that for the delete at the beginning. Uh, so I gonna try this out for delete at the beginning. 1, 2, 3. To release this, I just like the head equal head net, right? I just to remove this one, I change the head to this node. So right now this becomes the head and I remove it. And for remove it at the end, right? I travel to the end, right? I travel to I create the dummy node, and then I travel from the head to the end, and then at the before end, right? So I gonna just like how I can get like the node before end. I wanna check like them.net .net is not null, I guess, right? For example, I travel temporary from this node to this node. I gonna check like from this node. I gonna check to net together and then net, and then at this node I really see that I realize that this node pointing to null. So I gonna remove it by using like temp.net equal null, right? So right now for this node I gonna point to the null. So I gonna remove the connection with the node and delete a specific node. For the list with a specific node, node of 1, node of 2, node of 3, node of 4, node of 5 to remove as a specific node. For example, I want to remove as the index of 3, 2 for example. This is index of 0, this is index of 1, this is index of 2. So I want to remove this index. I want to remove this node. So what I really need to do is that I need to travel to this node, right? And then I want to check if this node dot data equal to the data I want. No. I just want to remove the nodes based on the index or remove the index. Okay, position. Okay, position is not the data. So this is my wrong, my bad though. So I'm gonna do the for loop to travel from the 1 to the input, right, to the index, right? A less than index. So for example in of 2, so it's gonna stop, this for loop gonna stop at this node, and then it's gonna do is that this temp node dot net equal temp dot net dot net. So it's gonna point into this point. It's gonna remove the connections with this index. So it's gonna implement 3 of them right here. For the public void remove head. This is the SK when the head null is a return and not do anything, and for the head it's just important to next node, just to remove to the next node. Time for AI. I don't need to write it. Remove and if has to noon. I just return right it's sk and then I gonna scroll the dummy node and then I gonna travel to the end while at noon right is on my this help me to implementation and publish for remove add index what is receive is the index of 2 for example and then another my bad though for the sk if the index equals 0 remove head if then I gonna perform the remove at the index if I gonna create the I gonna travel I create the dummy node and then I travel to dummy node to the index so for e1 and then a less than the index when it's out of the loop it's gonna when it's out of the scope of this for loop it's gonna stop at the previous node so from the previous nodes we just port into the next two nodes so it's gonna stop remove the middle node I'm gonna test it in the main but it's not give me any suggestion single list remove head singly nothing happened. Let's look back to my implementation for the remove head it's gonna check if this system is correctly implementation what happened with them I gonna ask my friend my teacher my professor small able to remove n or I need to cover the sk right it says me to cover the sk and I need to remove it right now it goes properly right First, I remove at the head. So the head is 3, so it's remove it, and this is after the list after removing the head. And then I want to remove the end. So right now it's remove this position, this one. And for example, if you want to I ask at the I remove at the index 1, so it's gonna remove this. So let's see. Why maybe I name is wrong, and then I display the list. Let's see, must work, right? It works probably. And let's see, have any API, another API. Search, find a node with the given value. With the given value. Okay. With the given value, for example, I have the list of 1, 3, 5, 7, and I want to find if the list contains the element 5 or not, right? What I really do is that I gonna travel throughout the list and check like if the node dot data equal to input, right, the element, if I gonna return yes or true, otherwise I return 4, right? If like it hit the end, like the node dot next equal null, I'm gonna return 4. So this is my implementation. Boolean for this one, I'm gonna just boolean search. I'm gonna name is element, right? And right here I display the dummy node. Oh, it's already have me to do all the thing, right? It's gonna go through the while loop, and then it's gonna check if the temporary data is what element. It's gonna return 2 immediately and return to get out the loop. Otherwise it's just moving, and the current node gonna point into next node. And if it's go through the scope of this while loop and it's not return anything, it means that it's must be false right now. So I return false. Let's search for element. By default, okay, on display as true, right? And now it contains element 5, it's gonna return true. But if, for example, I just push another number and so on, it's gonna check and return false. This implementations for the source element. For the node, update the node, right? It is the same, the logic for the searching is the same with the node, right? It's gonna check if the data is equal with the input element, and then if it's right, it's gonna train the value for the data for this node. Otherwise it's just like moving to the next node, and if it's out the scope of the loop, it's gonna return 4 if no this element is not provided, this element is not existed in the list. Sorry. And the second is the double linked list, right? Double linked list is like the list can have like a two pointer. It's gonna point into the previous one. For example, like I have this node, right? For the singly linked list, it just pointing to the next node. But like when I insert the new node, this one gonna pointing back to the previous one. And for the head node, right, the previous is null, right? It's pointing to the null. And then so I want to insert to the new element, the new node, right? It must to pointing back to the previous one. And for the last node, right, it's gonna point into the null similar to the single node. And to insert to the new element for this one, right, for insert to the head, what we really do is that we create a new node. Right, for example, I want to create a node of 5 and I want to insert at the head. So what I really need to do with that, this the new node needs to point into the head, and then the previous of the head pointing back to the new node, and this one, the previous of this one gonna point to the null, and we moving the head equal the new node, right, for this one. And to insert to the end, what we need to do is that we have to travel to the end, to this point, right? So we use the while loop, right? First we need to create a dummy node, and because if we use the head, it's gonna destruct the structure of the linked list, because each time we call internet, it's gonna adjust to the new one. So it's gonna destroy our list. So we need to use the dummy to travel to the end new, temporary, right, equal to the head, as while head dot net is equal e not null. So it's gonna stop out when it go out this while loop. It's gonna stop at the end, the last node right here, because the last node is important to the null, so it's not moving anytime more. So right now, first we need to create a new node of 5, right? And then for the net of this end node, is gonna point into this one. And for previous, for the new node previous equal for the temporary, right? So we make the connection back to this node, and new node dot net equal to null. And one advantage of this node is that like we can add the element at the end of the or the head or the tail as the bit O of 1, because we can keep track the tail, right? So we just add it without traveling again and again. And for the middle, insert at the surface index. For example, I want to insert 5 at this one, at this 0, 1, 2, right? I want to insert at the index of 2. What I really do with that? With creating, I want to remove, erase all this thing. Okay, this is enough for me to try. So right here, I create a new node of 5, and when I use the for loop to travel to this node, and when I use the temporary node, and this node is this one, right? And then the temporary, you're gonna point in. First, I need to have the connections with this node. So net the new node .NET equal to the temnet. So this one gonna point into this one, right? And then the temp node equal .NET equal to the new node. So this one gonna point into this. Alright, right now we need to reset the password. So first we are for the new node, right? New node equal and previous equal to a temporary. Temporary it is node right now, right? So we just set it back to right here. So it's pointing back to this node, and for this node, we're gonna write like new node .NET to go to this node, and then we go to previous, right? So it means that we're gonna go to previous of this node, and we need to point it back to the new node right now. So it's gonna equal to new node. So this is the for line to implement for this double LinkedList. And to travel through the list, so it's gonna provide indentation for the insertion and deletion. So first I create a new package for doubly LinkedList. I'm gonna publish for short, and then it's create a new class. It's the doubly right inside is create the inner class, which is the private class node, and for the data, sorry, it's the in, and I create like the net and previous node, right? I create a constructor. Appear again, appear. Okay. This is all this we need, and then inside we create a head. And first we want to like insert at the beginning. We should check by if head equal none. What we do is that we insert it has equal new node and tail equal to head, otherwise we just display a new node and then point into this new node to the head, and head previous to the new node, and head it resets the head to the new node. Okay, publish void insert tail. Similarly, we need to check if it's at the head we insert it like this way. Otherwise, we create a new node, and then we display the dummy node, and then we travel to the end. Right, it's gonna stop at the end, and the dummy nodes we gonna point into the new node, and the previous gonna point it back to the dummy node, right? the domain node is like the end node right now, and we set the tail to the new node. This is all the thing, and if we want to insert the subscripts in that, right, first we're gonna check if in that to equal to 0, which means that we insert as the head. We just call our API here. I'm sorry, that's in that, and we already need to know like the data, right? If and then equal to size, we insert at the end. Okay, this is our 2sk, and now we just implement the logic. That first we create the dummy node, right? Which already creates for me, and then we use the while loop. While in that, first we use the for loop for this case. We create the dummy node. After that, we now the timer is gonna stop at the previous node that we run. So from we just implement this, right? The new node net equal to temporary net, and temporary net equal to what I write in here. Temporary net to the new node, I guess. Oh, must be right. The new previous equal to 10, and another next previous to the new node. Okay, it must be worthwhile. I'm gonna tag it as the main. As common is out. Okay, I forgot to implement the display API. Right, we need to travel to the end. Right, we first display the dummy node, and then if the dummy node is not like the null, which means that it hit the end, and the end nodes and the new or the next is not null. We're gonna just move up like this way. This is just be the condition for this one up to stop. Boom, it's still the same to single list, right? And it's called the same, and then we implement for removing the API. If we want to remove as the head, it's just be like this. Let's see. Now let's see for example, if we want to remove this head, right? What we really need to do is that head equal for head net. Right now this one becomes the head, and a head dot previous equal to null, right? This is the thing that implement for removing from the beginning, and we want to remove from the end. I think this one, the previous one, right? Like the node dot, the condition we need to travel to the previous node right here. So we need to check like node.net is not null, right? When it is meet the condition, it's gonna stop, and then it's gonna meet to this. It's gonna stop at this node. The node of 3 is right here. We declare at the temporary node, and it's gonna point in. It's going to remove this one. So just basically just net is equal to null. So that's we remove the relationship with this node. And if we want to remove at the specific index, for example, for the index of 1, 2, 0, 1, 2, right? I want to remove at the index of 2 right here. First, I need to travel to this node first. When I travel to this node, I point into the net node. And the net node is gonna point in back to the current node. Okay, I think this is all the thing. So you're gonna implement it. Public void remove head, right? For the S, I think that it's already success me. So if the head is null, it's just return and not do anything. Otherwise, it's just move the head, and the previous gonna set it to null. And if I want to remove from the end, just me, okay. Right, I use a while loop to travel to this end, the previous end to remove like this way. I think the implement is kind of same with adding, but just do some different. Not much different, right? The SK if at the 0 or is with the side, you just call this API. Otherwise, we create a new node and create a dummy node, and this dummy node is gonna travel to the previous one, the previous position, and then this gonna point into the new node. Gonna point in. Oh, we don't need to create a new node right here. No, I talk about this in that, right? So I think this is the reason why it is different. So it's first gonna point into the temporary net, and the temporary net dot pre is equal to the temporary. This is all the point. Just trace me, I don't want to trace. Remove head, display, remove tail, display, remove surface index, and display. Space 2 was just 1. Because we don't need the data, we just need the index. Let's see. Right, the hash right now is 3, and if we remove the hash, it's gonna become this list, and when it's removed at the end, it's removed it 78. And if you want to remove at the index of 1, it is element, so it's removed it correctly. For the source and update the node. For the source, I think we just the data, and if it's the data, we just return it. Otherwise, it's return nothing. Okay, I just now I'm gonna go to circular linked list. circular linked list is this kind of list. I'm gonna draw it out for. I think it is this one. It's similar to this one. Anyway, this is the first node, the second node, the third node. Maybe it is because it's named circle, so I just try to draw it in the circle. Right? Even if we just draw it like in a right, this is the head node and this is the tail node, right? Right now at this point it is still similar to the singly linked list, but the difference is that for the tail it's gonna point into the head. So this is the whole point. So to insert the element for the double single list, to insert the element for this, right? For example, we want to insert at the beginning at the head. We first need to create a new element. For example, I name it as element seed, and the head gonna change to this one. Head equal new node. Now first we need to point this one first, right? So I think it will be a new node dot net equal to head net, and then the head equal to the new node. Done, nearly done. And this we need to set the tail too. So the tail equal tail dot net equal to the head, the new head, right? After we assert to the new head, the tail need to point into this head, and what we need to do is that the SK for this one is that like if head is null, right? We just create a new node, head equal to new node, and tail equal to head, which means that it's pointing to itself. The tail is the head is the tail. It's all the point. We just create a new package right here. New package, circular. This is the whole name, the right name for this. And then it's right, the circular linked list collection. For the inner, I declare like the inner class, private class node, right? It for the inside of this node is similar to singly list. It don't contain the pre-list, right? We can to implement like the like two pointer here that's gonna point to the previous one, but to keep it short I just like use like the normal single list for the circular one. I'm gonna contain the head, the tail, and the side. For example, I want to insert at the beginning, it's just at head, right? It also says for me if the head is null, it's just pointing to it's just create a new node, and the tail is equal to the head, and the tail net is head load. It also the head. Also why we create a new node and then new node, because this is the common code, we can put it outside for short in some way, right? And then if we want to insert at the end, because we already keep track the tail. So the tail here, we just insert it similarly. So it's provided to insert, we don't need to travel back. We don't need to travel. If the head is noon, it just creates the new head and the tail is head. It is similar to this plot, and you want to insert the tail. First, it's create a new node, and then the tail next is the new node, and the tail. Because we already keep track the tail, so we don't need to travel to the end, right? Otherwise, we have to travel to the end if we don't keep track the tail. Okay. So right now we have to travel from the end to we have right now we did, from the provided solution here it's create the dummy node, and then it's create the new node for the data. So we create a new node, and then as the inserted head is going to call this API. If just in that it was a side, we call it API. Otherwise, we travel to the previous of the index, and then we're going to insert it to the net, and the net is equal to the new node, the temporary, the previous one. We press the connection, and the previous one gonna point into the new node, and the new node gonna point into the next node of the temporary. This is all the point. I'm gonna press this in here for virtualization. For example, if we want to insert at the end, right? Let's see this one, right? If we want to insert at the tail, right? We want to have a new tail. We have to travel to this tail, right? We have to travel from until like the temple before we declare like the dummy node, and then we travel until the dummy dot next is not noon, right? If it's equal to noon, it's gonna stop. It means that we no. If the tail, if the next equal to head, right? It's not to noon, like the temporary dot net equal head, not equal head, right? It's gonna move in all the while. So after this while loop equal to tail net, right? So it's gonna move into the tail, and then at this point, we really do is that we assert the new node to the head, new node dot net, new node dot net equal the head, and then the tail dot net equal the new node, and then tail equal to the new node. So we just insert to the new node right here, and this one just put into this whole the point. And if we want to insert a subscript index, for example, for 0, 1, 2, I want to insert an index of 2. I travel to previous node right here. This is the index 1, and that index 1. First, I need to have the new node supporting to the remaining one to keep the structure. So new node.net equal to the temporary.net. So this one apply to this one, and then the temporary.net equal to new node. Done. This are the point when we insert. We're gonna test this in the main. Dress me. Circular sticky list. And to display this one, I forgot. We need to set condition, right? For the while loop, first we declare the temperature dummy node temporary is equal to the head as while temporary dot net is not head, right? We just print this out as this way. Come back to the main, see. Three, two, three, one. What happened? We forgot to print out the end node. Right, this is the thing to see it appears correctly. Because we set condition that if the net is not equal to head, so for the tail it will not like print the tail correctly. So we need to print it like this way. Okay. Uh, for deletion, I think it's called a sim logic. Uh, so I just draw this out and not like draw the code. Let's see. For the list from beginning, for example, it means that we're gonna remove the head, right? So first, like we're gonna like the head equal to head.net. So the head is become this one, and the tail right now, and then we fix the tail.net to head, right? We point into the new head. So we point on this one. This is gonna remove this head. It either inserts at the beginning, and we want delete at the beginning. If we want to delete from the end, let's see, 1, 2, 3. We want to release from the tail, so we need to travel to the tail, right? We use dummy and equal to the head, and we travel to the tail, and here at the tail, and we set the condition to travel. We not to travel to the tail, but to travel to the previous node of the tail. This means this one, right? So we set the condition for the while loop that while temporary dot net not equal head, we're gonna stop, right? So it's gonna stop at this point, at this node previous to the tail node, and then this one we at this node we're gonna point into the head. So temporary dot net equal to the head, and then we train the tail equal to temporary. So this one becomes the tail, and we'll remove this one. And for specific location, 1, 2, 3, 4. For example, we want to remove it at this index 0, 1, 2. At the index 2, first we need to travel to index of 1. So it's gonna stop right here. Right, it's gonna travel to the while loop while the temporary node at this one, right? And then we remove it. We use like temporary .net equal to temporary .net. Let's see. No, .net. What we first do is that temp.net equal to temp.net. Right, we dot to a 2 point right here. So that's we remove this one. And we also include the SK, like what that is equal 0 or that's equal the side or the tail, right? So that we can physics correctly. So it's all about the recap about the LinkedList, some basic API. Right, this is all a thing.